Hello everyone, welcome to this video. In this video, we shall be looking at question number 22 from exercise 9.3. So let's have a look at this question. It says that if the pth, qth and rth terms of GP are A, B and C, right? So the pth term, that means we are taking all the terms like this, A1, A2, A3 and so on of our GP. Why? Because here A is already been taken in the symbols of this question and small r has also been taken as the symbol of this question. So we are taking A, right, A as the first term and capital R as the common ratio. So here the pth term, that means AP is given to be small a, the qth term is given to be small b, and the rth term is given to be small c, right? And we know the formula for the general term. It is equal to an is given by the first term a multiplied with common ratio raised to power n minus 1. So making use of this formula, substituting n is equal to p once, substituting n is equal to q, and substituting n is equal to r one by one into this formula, we would have ap is equal to a r raised to power p minus 1. This is given to be a. So let's mark this as equation number 1. Now when n is q, we have aq is equal to a r raised to power q minus 1, which is given to be b. So let's mark this as equation number 2. And when n is equal to r, we have ar is equal to a r raised to power capital R raised to power small r minus 1, which is given to be equal to c. So let's mark this as equation number 3. Right? Once we have equation 1, 2, 3, we wanted to prove this result. Now notice here that how can we prove this result? What we can do, we can take the left hand side of this thing and prove that this is equal to 1. So let's take the left hand side here, a raised to power q minus r, b raised to power r minus p, c raised to power p minus q. Now we know what is a. Using equation 1, it is equal to, we can substitute the value of a as ar raised to power p minus 1. We can substitute the value of b as ar raised to power q minus 1 and the value of c as ar raised to power small r minus 1, correct? Once you substitute all the values using equation 1, 2, 3, we need to simplify the powers. So here you can very clearly see that the first term has the power q minus r here, the first term here has the power r minus p, and the first term a here has the power p minus q. So that means you can take a raised to power all these powers added together, right? So that you would have a raised to power q minus r plus r minus p plus p minus q, right? And here you can very easily see this q and this q cancels, this r and r cancels, this p and p cancels. So therefore a raised to power becomes 0, right? And what is something raised to power 0? It is always equal to 1, correct? Okay, next, what about r? Capital R. The power of this capital R here is p minus 1 multiplied with q minus r. So this is what I have written. Next, here what is the power of this capital R? It is q minus 1 multiplied with r minus p. This is what I have written. And the power of capital R here would be r minus 1 multiplied with p minus q. So here I am using the result a raised to power m plus n. It is equal to, sorry, I am using the reverse result, a raised to power m into a raised to power n. It is equal to a raised to power m plus n. When the bases are same, powers or the exponents get added, right? So this is what we are using here. So now what we can do, we can multiply the terms of these three brackets so that we would have these terms. Now here you see each term is cancelling with some other term in this expression. So this pq cancels here with minus qp, minus pr cancels with plus rp, minus q cancels with plus q, plus r cancels with minus r, plus qr cancels with minus rq. So here also the power becomes equal to 0. Hence a raised to power 0 is also 1, r raised to power 0 is also 1, 1 into 1 is 1, which is equal to right hand side. Hence our result is proved in this particular case, correct?